Now let's talk about open tubes. On an open tube, remember you have to have an antinode at any open edge. So right there. All right. Now, the fundamental is the shortest wave that will be supported. And if you have an antinode there and an antinode there, clearly just straight is no sound, so that's kind of boring. So you have to have one node in the center. Now it turns out if the length of my tube is L, the length of my tube is always L here. All right, this is half of a wavelength. I know this is confusing, but if you just sketch a wave like this, all right, and then sketch in your equinodal line. All right, this is how I have to do it. All right, this is the fundamental for an open tube. So this is half of a wavelength. This right here is one wavelength. All right, where this is a half. All right, this is 3/2 of a wavelength. And it turns out if you can count the antinodes, this will help you figure out which fundamental you're on. And remember, once you find the fundamental, the nth is equal to n times f1. So you can always just find the fundamental, and then any other frequencies you can find by calculating n times whatever your fundamental is. Now you see this is the second harmonic, and it's hard to see this, but let's see if we can do it this way. From antinode to node is 1/4 of a wavelength. So 1/4 of a wavelength plus 1/4 of a wavelength is 1/2 a wavelength. We can do it this way. But now, what is this? Okay, this is 1/2 of a wavelength from here to here. 1/2 plus 1/4 plus 1/4. 1/4 plus 1/4 is 1/2, so this is one wavelength. Let's see if we can do this one. From here to here is 1/2, 1/2, 1/2, 1/4, 1/4. So 1/4 plus 1/4 is 1/2, plus 1/2 plus 1/2 is 3/2 of a wavelength. All right, let's try this one. This is 1/2, this is 1/2, this is 1/2, this is 1/4, and this is 1/4. So I've got 1/4 plus 1/2 plus 1/2 plus 1/2 plus 1/4. So that's 1/2, 1, 2. So this is 2 lambda, which is the same thing as 4 lambda over 2. So you kind of have the idea. So this is 1/2. So I've got 1, 2, 3, 4. So I have 4/2 of a wavelength. And then I'm going to add here 1/4 plus 1/4. Fractions, aren't they great? 1/4 plus 1/4 is 1/2. So 4/2 plus 1/2 is 5/2. All right. That was probably a little too much fun. All right. Calculate the speed. So we're looking for V. If a 292 hertz tuning fork resonates in an open tube when it's 28 long. Okay. Now I know Fn is NV over 2L. That's the only formula I have. In this case, I'm going to assume N is 1. If I don't tell you, N is 1. All right. So I'm looking for V. So to find V, I need to get rid of my denominator. So I need to multiply both sides by 2L. So 2L times Fn is NV. So now I'm going to divide through by N. It's okay that N is 1. So V is 2L Fn divided by N. All right. So V is 2. L is, okay, 27.8 centimeters. I need to convert this to meters. It's 0.287 meters. 0.287. Fn is 292 hertz divided by n, and in this case n is 1. All right, so let's see. 2 times 0.287 times 292 is, this is 167.608, and it's divided by 1. Now, you don't have to do this step. 0.608 meters per second. That's too big. It's 168, 167.6 is fine. Now, what are the first three harmonic frequencies in, let's see, L is 0.68 meters. Let's try that again. L is 0.68 meters. How do I know L? Because it's 0.68 meters long. That's open at both ends. Speed of sound is 345 meters per second. So, Fn is NV over 2L. So let's do F1. F1 is 1V over 2L. So it's just 1 times V is just V. So it's V over 2L. You don't have to do these tiny steps here. So it's 345 divided by 2 times 0.68. Now you need to multiply your numerator straight across first. So this is 345. Now to multiply your denominator. 2 times 0.68 is 1.36. So I'm going to bring this up here. So F1 is 345 divided by 1.36, or 253.6, let's call that 68 hertz. Now I can go back through and plug into here for the next couple, but let's not. Let's do F2 is 2 F1, because I know, where's my formulas? Fn is in F1. All right, so this is 2 times 253.68. See, this is a much easier calculation. And I get F2 is 507.3 hertz. F3 is 3 F1. So it's 3 times 253.68. So 761.03. There you go. It's first three harmonics. What are the first three harmonics in a 0.75 meter long pipe? So L is 0.75 meters. That's open at both ends. In this case, V is 338 meters per second. Now, let's see, I know Fn is NV over 2L. And I also know that Fn is N times F1. So let's find F1. F1 is 1 times V, which is 338, divided by 2 times 0.75. Multiply your numerators. So this is 338 divided by, now 2 times 0.75 is 1.5. So 338 divided by 1.5, 338, let's do this correctly, is 225. Did I do that correctly? Hertz. Well, that's not what I have up here. So let me run through this real quick. L is 0.75. Speed of sound is 338. All right, so it's 1 NV over 2L. 338 divided by 2. Okay, so my answers up here are incorrect. Happens. I think what I did with a closed tube, that's what that looks like. All right, so if F1 is 225.3 hertz, F2 is 2 times F1, so it's 2 times 225.3. All right, so that's 450. Let's call it 0.7 hertz. It's 0.667. F3 is 3F1. So it's 3 times 225.3. And that gives me 676 hertz. There you go. And it's open.